Right, we move on with our trigonometric graphs. In this particular case, we want to look at how they set this particular section in 2008. Remember, in this section, you'll be getting two types of questions. The first one, you might be asked to solve these graphs algebraically, as in this one. The next one is to sketch the graph and be able to interpret those graphs as well. Right, let's look at the first one. We're given two functions here, cos 3x as well as sine x. When I look at those two graphs, I can see which one is easier to sketch and which one will be more difficult. This one is easy. It's a normal mother graph. But this one, something has happened here, the p. So to find the period of this graph, I've got to take the original period, which is 360, and divide by that 3 to find the actual period. Now, let's respond to the question now. Solve for x. If f of x is equal to g of x, we are given these two graphs, this graph f and this graph of g. Where are these graphs going to be equal? Remember that these two graphs are only equal if and only if they intersect. They'll be equal at the point of intersection. So that's what we're actually looking for. In actual fact, when these two graphs are the same, we're looking for the points of intersections. Let's work it out. They say that f of x is equal to g of x. Let's equate them. What is our f of x? It is cos 3x must be equals to, we respond to the question, g of x. In this particular case, it is sine x. Remember, this question has got big marks, so you open your eyes when you tackle it. Okay, the next thing that I need to do, I've got to make this one ratio. How can I change this to be sine or this to be cos? Remember that you've got to involve 90 degrees there. Let's change sine for this case. If you like, you can change cos. If we change sine, what will I have? This means cos 3x is the same as cos again. It is the same as cos into 90 degrees minus x, or x minus 90. 90 minus, if I include 90 minus, I'm taking it into the first quadrant. That's what happened here. Because there is 90 here, cos will be sine. So the actual answer there, if I work this one out, it will be equal to sine x. So these two are the same. Why am I bringing in 90 degrees? Because I want this ratio to be the same as this ratio. Since this is cos x and that is cos x, I look for arc cos of that. Now, if we do that, these two will go. In other words, this will go and that will go. I'll be left with the angles, which is 3x, the same as 90 minus x. Right. This is what I have so far. 3x is equal to 90 minus x. Remember here, I'm talking about the cosine graph. When you talk about the cosine graph, if you remember your Cartesian plane, this is 0, this is 90, this is 180, this is 270, and this is back to 360. All students take Coke. All students take Coke. Now, all ratios are positive here. Sine is positive here. Tan is positive here. And cosine is positive here. Why am I bringing that into play here? Because I'm looking at cosine here. When I look at this cos, it is positive. Where is cos positive? Cos is positive in the first quadrant and the third quadrant. Remember how we call the first quadrant. The first quadrant is just called theta. But the third quadrant, the fourth quadrant, it will be 360 degrees minus theta. Right. This is what we have so far. 3x is equal to 90 minus theta. Remember what is it that we're doing here? We're just solving for x. Right. This then will be, because this is a general, in fact, when you do these problems, you must be able to understand your general solution as well. So from here, I can say, if I'm doing the first quadrant, this becomes my theta, plus 360, n, where n is an element of z. I can also do that. If I'm solving for x here, I've got to take this one, this side. What will I have? What will I have? Remember, in this case, I'm dealing with the quadrant 1. But I still have to go and do quadrant 4. When I'm doing quadrant 1, then what will I have then? Take this one this side, it will be 4x. 4x will be equals to 90 plus, remember this x has gone this side, it was positive, we got 4x, this is 90 plus 360 n, where n is an element of integers. Right, let's see what happens here now. This is important that we get into this stage. Now, look here. This is what I have. I've got to find x. How do I find x here? I've got to divide everything by 4. If you divide this by 4, I will have x is equals to. If I divide this by 4, what is 90 divided by 4? It's 22,5. This should give me 22,5 because it will give me, divide by 2, it's 9, it's 45. Yes, 22,5. Plus, divide this by 4, 360 divided by 4, it is 90. 90 n. So this is what I have. Now this is the stage where I wanted to be. This is the main important step. I wanted to come to that general solution, to that machine, which will guide me into finding this interval as well. This is going to guide me into getting into that interval. Remember what I said, that here we're just dealing with the first quadrant. But this is not the only quadrant that we're dealing with where cos is positive. Cos is positive in the first quadrant, and also cos is positive in the fourth quadrant. But how do we call the fourth quadrant? We just call it 360 minus. How do we call the first quadrant? We just call it theta. Hence, the first quadrant, we just call it our angle. In this particular case, our angle was 90 minus. Let's do this thing. If I'm dealing with the fourth quadrant then, what will I have there? I will then have 3x. Remember now, this is the fourth quadrant. 3x will be equals to, how do you call the fourth quadrant? We call it 360 minus. So I will have 360 minus my angle. What is my angle in this particular case? It is 90 minus x, minus into 90 degrees minus x, minus that angle, plus 360, n, where n is an element of integers, of z. Right, that's why it has so many marks, because we've got to work on both quadrants. Now let's see what we have here. Let's break these brackets. So we're going to have 3x, thus becomes 360 degrees. This times that, it is minus 90. This times that, it will be plus x plus 360 n. Remember, we are required to solve for x. So we put all the x's on the same side. So this is a positive x. If we bring it this side, it will be negative. Then you'll be left with 2x this side. It is equals to, what is 360 minus 90? 360 minus 90 is 270 degrees. Remember, angles are measured in degrees. 270 degrees plus 360 n. This is what we have. We're not looking for 2x. We're just looking for 1x, not two of them. So we divide everything by 2, including the period. We divide this by 2, we'll be left with x is equals to 170 divided by 2. This divided by 2, it's 1, and 70 divided by 2 is 35. So it's 135 degrees, plus that divided by 2, it's 180. 180 n. This is the machine that we wanted to get. Now that we've got our two machines, then we can be able to find the actual values of x. Remember, our values of x must be between minus 90 and 180. Now, let us find the actual values now. Let's find them. And see in how many places will these graphs intersect. The first one, let us use the first machine and check it. Look here. Whenever we do this, others, they use k here or n. The values that we use here, it's 0, 1, 2, and 3, or minus 1, minus 2, and minus 3, depending on the interval. It will guide you, but those are the values that we'll be using to check whether this is part of the solution or not. Let's start with this one, the first quadrant. If we push in 0 here, what is the value that we are going to get in this part? So 0 times 90, it will be 0. This is gone. This is the only solution that we will get here. This is the first solution that we get. Now, if we get that solution, which is 22,5, because 0 times 90, it is 0, plus 22,5, it is 22,5. So it's 22,5 within this range, between minus 90 and 180. Yes, it is within that range. So our first x is equals to 22,5. So this is part of our solution. This is the value of x where these two graphs are the same. Because if I push in 0 here, 0 times 9, it's gone. It is only this one, which is 22,5, which is our theta in this particular case. Let's move on. What if this is 1? What if that is 1? If we take 90, you multiply it by 1, it will be what? It will be 90. 90 plus 22,5. We've got 90 plus 22,5. What is it that we get there? We get 112,5. That is the value when you push 1 here. The actual value here will be 112,5. Is 112,5 within this range? Yes, it is within this range. 112,5. Ukhona part kwe number iphakathi kwa minus angles phakathi kwa minus 90 no 180. Yes, it is part of our solution. So this is another solution where these two graphs will meet. It's 112,5. Remember what we started with? We started with 0, then we move on to 1, which gave us this. Now, let's check what if we move into 2. If we push in 2 here, we're going to have 90 times 2, which would give us 180 degrees. But this says we must not go beyond 180 degrees. So 180 plus something, it will give us something that is beyond there. So the value of 2 is not going to lead us into our solution. Let's go back to the negative values now. If we push minus 1 there, 90 times minus 1, it's minus 90. So it's minus 90 plus 22,5 plus 22,5. We get a negative value of minus 67,5. Minus 67,5. Is minus 67,5 between these two angles? Yes, it falls within that range. Minus 67,5. It falls within that range. So our other x will be equals to minus 67,5. Right. What is it that we check there? We checked minus 1. Let's check minus 2. Let's try minus 2. It will be minus 180. Minus 180. This is already minus 180. This is not 90. So this is not going to give us. Let's check how many values that we have here. If we push in 1 here, we got 90. 90 plus this, it gave us 112. We pushed in 0, it gave us that. If we push in minus 1, it gave us minus 67. If we push in minus 2, this will be minus 80. No, it's not going to give us that one. Now, let's go on to the other machine. Let's see how many values that we have here. Let's go over it once more so that we'll get the grasp of it. We started with minus 2. If we push minus 2 there, it will be minus 180. It's minus 180 plus 22,5. The value that we get there is 157. It is beyond this one. It is negative 157. So we can't take that one. If we take minus 1, if we take minus 1 here, it's minus 90. It gave us minus 90. Let's confirm it. Minus 90 plus 22,5. The solution there is correct. It's minus 67,5. We do have that one. If we take 0, 0 will give us 22,5. What if we take 1 there? 90 plus 22,5, 90 plus 22,5. It gives us 112,5. Right, let's move on to the other side and see what happens there. If we take here, let's see, if we take 1, 180 plus 1, it's already going to give us a value that is above 180. So we can't take 1, we can't take 2. If we take 0 here, let's see what we have here. If we get 0 here, 180 times 0, it will be 0. We'll only be left with 135. Is 135 within this range, between minus 90 and 180? Yes, it is within that range. So our x in this particular case will be equals to 135 degrees. Right, let us check minus 1. So if we've got minus 180, it's minus 180. We add 135 there. Let's see what we get. 135. We got minus 45. Is minus 45 within this range? Yes, it is within that range, minus 45. So x is equals to minus 45. How many solutions then do we have? 1, 2, 3, 4, 5. What is this saying to us? It is saying to us that these two graphs will be interacting in 5 different places. Thank you.